Exercise 12.2, Problem 11, discussion. A box contains 10 white, 6 red and 10 black balls. A ball is drawn at random. Find the probability that the ball drawn is white or red. Okay, it's a very important point here is that these cases, this is a particular case where it is mutually exclusive events. So I'll explain that little later. But anyway, the box contains 10 white, 6 red and 10 black. So totally 10 plus 6 plus 10, that is 26 balls. A ball is drawn random. They are asked to find white or red. Okay, or. So very important, or. So which means you have to use the addition theorem, right, of probability. Right. Okay, I'll explain when it comes. Mutually exclusive means that when a ball is drawn, it can be only white or it can be red or it can be black. So the moment it comes out as a white, then the other two are excluded. So that is why we call it as exclusive, mutually exclusive. One happens, it excludes all other happenings. But now let's take the previous case. I think it's problem 9, where a student was were taking maths quiz, science quiz, or both, right? So a student will take maths quiz or science quiz or both, right? They can take both maths and science. So their events are not mutually exclusive. That is, taking maths quiz and science quiz are not mutually exclusive because a student can take both maths as well as science. And that is why in that formula you will have probability of A plus probability of B minus probability of A intersection B. But here, when a ball is drawn, it cannot be white. It cannot be white and red, and it cannot be red and black. It can be only a white or red or black. So the probability of that A intersection B is 0. Okay. So the formula will get modified as probability of A plus probability of B. Just keep that in mind. We'll work it out. So what is given? Number of white balls is 10, number of red balls is 6, and number of black balls is 10. Total number of balls is 26. Probability that the ball is drawn is white or red. The formula is probability of A union B equal to probability of A plus probability of B. Here A is the event of drawing a white ball. B is the event of drawing a red ball. And there is no A intersection B here. Minus probability of A intersection B, because when a ball is drawn, it can be a red ball or it can be it can be white ball or a red ball, because it cannot be white and red together. So that A intersection B will never happen, and it is 0, and that is why it is excluded. So in all these cases, whenever you have these balls, so most of the time it is mutually exclusive. There may be some special cases, but in all these cases it is mutually exclusive, right? Now let's start putting the steps. Let A denote the event of getting a white ball, and B denote the event of getting red ball. Okay, find n of s. What is n of s? It is total number of balls. That is 10 plus 6 plus 10. That is 26 balls. Okay, and n of A, which is a number of white balls, which is n of A, which is number of white balls. In this case, it is 10, and n of B, which is number of red balls, which is 6. Okay, right. Then calculate P of A, which is nothing but n of A divided by n of s. That is number of white balls divided by total number of balls. N of s is nothing but total number of balls. We have given it here, right? This is very important. Please note, n of A is number of white balls, n of B is number of red balls. And we don't have n of A intersection B, that is balls which are white and red. Okay, that is why they are called mutually exclusive events. Okay, now, so probability of A is n of A by n of s, which is nothing but number of white balls divided by total number of balls. Similarly, probability of B, that is probability of a red ball, can be calculated. Once done, then all you need to do is substitute those values here. Okay, this we know and this we know, so which means this can be calculated. What is this? Probability of A union B is probability of drawing a white ball or a red ball. U means or, intersection means and. Okay, A or B, which is what we are asked, probability of drawing a white or red ball. So this is the formula, and we know P of A and P of B. Substitute that and simplify, you will be able to get probability of A union B. Okay, so now let's go to the solution. The number of white balls is 10, and the number of red balls is 6, and the number of black balls is 10. Total number of balls is 10 plus 6 plus 10, that is 26. Let A denote the event of drawing a white ball. What is n of A? The number of white balls. Number of white balls is 10. So n of A is 10. Probability of A is n of A divided by total number of balls. That is number of white balls divided by total number of balls, which is 10 divided by 26. Right? 10 divided by 26. Let B denote the event of drawing a red ball. So n of B is number of red balls. How many red balls are there? There are 6. Okay. So n of B will be equal to 6 and P of B will be n of B divided by n of S. That is number of red balls divided by total number of balls. That is 6 by 26. Right. Then all we need to do is substitute that in the addition theorem. Probability of A union B is probability of A plus probability of B. As events are exclusive, mutually exclusive, A intersection B will not be there. Substituting that, probability of A, which is 10 by 26, and probability of B is 6 by 26. Substitute that, 10 by 26, 6 by 26, that is 16 by 26, or 2 will go 8 times, 2 will go 13 times, so it's 8 by 13. The probability of drawing a white or red ball is 8 by 13. Okay, so I hope I made it clear. If not, please go through one more time, it will become clear. Thanks for watching this video.